Okay, we took a couple minutes and we did a practice test. So if you don't have this paper in your packet, I had a couple notes on there. It's a property quiz. It's after 1.5 part 2 or 1.5 practice. We're using this as a practice quiz. So if you don't have it, you can pause the screen right now, write this down, and try it yourself as a practice quiz. We're going to take the time and go over it. So anything to the power of 0 should always be 1. These are your properties. They're in your notes. They're on our yellow property sheet. We need to know them in order to use them. All right, if I have a negative exponent, that tells me to take the reciprocal. So this is over 1. It becomes 1 over a to the positive n. That's what we're looking for there. Next rule, when I multiply the bases, what do I do to the powers? I keep the base and I add those powers. Okay, so when I multiply the bases, I add the powers. So this is, I think, day 4 of going over these power properties, if I'm correct, at least day 3, then maybe our 3rd day. When I have division, I keep the base and I subtract the power. So these go hand in hand. A power to power becomes multiplication of powers. So if you guys think about your order of operations, I'll write it over here. Please excuse my dear Aunt Sally. We all know those order of operations, hopefully neater than that. And if I actually take the time to think about these, this might help me. When I have multiplication, multiplication drops to addition. So multiplication of bases drops to addition of powers, because multiplication is repeated addition, isn't it? And then an exponent to an exponent, a power to power, drops to multiplication, because repeated multiplication is an exponent. So if you have trouble reminding yourself of those rules, multiplying bases drops to addition, power to power drops to multiplication. And then if multiplication is addition, then division would lend itself to subtraction. Okay, so division to subtraction. Maybe that helps. All right, this one, I can distribute a power over multiplication and division. So everything inside, if there was a number in here, it would get it too. So a to the n, b to the n. We have to watch our negative signs too. Same thing with division. Everything inside gets that power, a to the n over b to the n. I cannot distribute a power over addition and subtraction. So I'm going to write this at the top. If you had something like x plus y squared, this has to be written x plus y times x plus y. You cannot make it x squared, y squared. And then we would FOIL this. I know that we're going to be doing this later. And FOILing, you do your first, you do your outer and inner, and you would get 2 of these xy's, and your last is y squared. So we're not focusing on this now, but I wanted to show you why can't I just write x squared, y squared? Because I'd be missing that middle term. You cannot distribute a power over addition and subtraction. So be careful with that. I can distribute it over multiplication and division. Okay, now, this is sort of a mix of 2 rules. We've got our negative exponent and we've got our fraction. So we would make this b over a now to the power of positive n. So I dealt with the negative sign first, and then because I can distribute that power, it'd be b to the n over a to the n. So I'm really looking for that final answer that you cleaned it up, but the big one on this is that the whole fraction flips, and then I can distribute that power. Okay, now, I know that these weren't on our yellow sheet, so I think we might add them. But you know how I have multiplication with powers? Where is it? Down here, sorry. I have multiplication with the power on it. I can distribute that. Well, a square root is the inverse of a power. A square root is the same as saying I have ab to the power of 1/2. So if you think about using my power property, I could write this as a to the 1/2, b to the 1/2. That's what I can do. The square root is the same as a power of 1/2. It's a fractional exponent. So if you took the square root of 4, you'd get 2. If you took 4 to the 1/2, you would get 2. So if I can distribute a power, I can break up a root. And if you remember, we did this. This is one of the first things we did with roots, was break them up with multiplication. And that way we could take a number like 20 and make it 4 times 5. So we already knew this rule, but I wanted to show you that it is exactly in relation to what we have with our power products. Okay, with that in mind then, if I can distribute a power, this is root is the same as 1/2, so we can separate the square root of a over square root of b. So again, those are old rules that we used. And now we want to classify. So the first thing I need to do with classifying is clean it up. So I've got a negative sign, don't lose that. The square root of 25 is 5 over 2. Okay, yeah, this can be negative 2.5 or 5 over 2, but I can't go further. So first I'm going to tell you that it's a real number, and you can write out the word real or use the symbol. Is this rational or irrational? We need to know this, guys. Tell me the definition before we start. Well, it can repeat, but it can also terminate or be written as a fraction. Okay, so rational can be written as a fraction. It can repeat, because think about 1/3. 1/3 is written as a fraction, and you said it can repeat, right? Anything that repeats can be written as a fraction. It might not be it might be a big fraction, but it can be written as a fraction. Anything that terminates, that ends, negative 2.5 done, that can be written as a fraction. So this would be considered rational. To be irrational, it goes on forever, right? Or a dot, dot, dot at the end. Pi, square root of 10. Okay, 36 over 4. It reduces real nice to a what? A 9. Okay, so with that in mind, it is real. It is rational or irrational? It's rational. And then I need you guys to think about the hierarchy. What's the next set of numbers? And you need to know those terms. The next big set. So you've got real, and then you've got rational on one side, irrational on the other side. If it's irrational, you're done. What's the next set under rational? Positive and negative whole numbers. What's the word for that? Positive, what is it?
Natural numbers.
Natural numbers is the smallest set. Go bigger. Integers, right? Integers. This is an integer, isn't it? Integers are positive, negative whole numbers. So you went small. So we're going to go integers. And then next in line for integers, I already said it. If integers are positive and negative whole numbers, the next thing is a whole number. What's the smallest whole number? Remind you that it starts with a big whole. 0 is your biggest or smallest whole number, right? And there it is. It's positive. So it's an integer, it's a whole number, and then it's natural. What's the smallest natural number? The smallest natural number is 1. So 1, 2, 3, 4. You guys need to know that. That will be on your quiz. Okay. So make sure you use this. Be honest with yourself. How'd you do? I know it's a Monday. And then I would use this as a practice quiz. I would cover it up, fold it over, whatever, and then I would see if I know my properties.